Hey guys, Brian back with another video today. I'm going to be showing you how we installed this basement utility sink with an inline water pump, PVC drain, and copper piping. If you want to see how we did it, stick around for another episode of Home Projects. So the utility tub that I'm using is a 19-gallon tub kit. It comes with a faucet, P-trap, and all the hoses and stuff that you need. The parts are a little on the cheap side. The valve is pretty much a throwaway, and the faucet's all plastic, and I really dislike using metal hoses with metal threads on plastic threads. They tend to cross thread and they don't make a really good seal. So I had to do this again. I probably purchased the parts separately. I'll put links in the description anyway so you can check it out, but just keep that in mind when you're purchasing this. So the first step is to take a screwdriver and a hammer and knock out the 3 center holes for the faucet and insert it in place. Keep in mind that these are all plastic parts, so you want to hand tighten them only and do not use any hand tools for this. So while you're going to need for most threaded connections to use Teflon tape, when you've got these rubber gaskets inside them already that seat on the plastic thread, you don't need to actually use Teflon tape with them, and you can just put them right together. And once we get this hose pushed through the stem of the spout, we're going to connect that center water connection for our mixed water supply to the sink. Again, remember this is hand tighten only. This is plastic on plastic. You don't want to break these with hand tools. And the last piece of the hose is put a counterweight, and this helps you put the hose back in place, and you want to put this right above the loop so it gives you enough slack. Next, we're going to install the braided stainless steel sink hoses. These are for the hot and cold water supply. Again, you can tighten these with hand tools, but just keep in mind that you can easily cross thread these, and you really want to check and make sure you're not doing so. With all the hoses in place, we're ready to put the legs on, and you basically just tap these in place. They're a friction snap fit in place, and they bend as you put them farther down. And once we get the legs in place, we're going to put the levelers, and these just go in with fasteners. Next, we're going to put a nice nailer board on the wall. This is a 2x6. I made a nice length, and I'm putting this on a concrete foundation. So I'm going to use Tapcons, and I'm going to pre-drill them with a rotary hammer drill, which makes this a breeze. And this will give me a nailer so that I can put all the pipe clamps and mounts on this directly without having to screw each one into the concrete. And remember, when you're working with Tapcons, be sure to use a drill with a low torque setting so you don't overdrive and strip them out. Working with copper pipes is very easy. All you need to do is mark and cut your parts to length. In this case, I'm using a rotary cutting tool. It's a hand tool that applies pressure as you turn it around until it snaps off. And then what you want to do is make sure that you clean the inside and outside out really well with a wire brush tool like this one. And the reason why you want to clean out the inside, most importantly, and actually deburr with a deburring tool, is that you don't create cavitation, which basically erodes the pipe in a long period of time. And then now I'm taking my part fittings, I'm kind of making a small assembly so that I can fit it in place and figure out where I need to cut the stuff. I'm actually going to cut this old valve out. These gate valves are really annoying in time. They tend to leak and you have to redo the packing nut sight. I really like ball valves. At every chance I pretty much replace these old gate or globe valves with ball valves. You want to make sure obviously that your whole house water supply is off before you do this. You're going to get a little residual water, and you can open up your taps to help that water come out even faster. Again, cleanliness is the most important thing to sweating joints. You really need to make good, clean connections. You need to deburr the inside and the outside, and then clean it, especially if it's an old pipe like this, so that you make a good connection. Now I'm applying a lead-free solder paste. This is going to go on the outside of the pipe and on the inside of the fittings. And I'm putting in my ball valve, a little stem to bridge the gap between this and another T. And I'm going to tee down with a 45 down to my water pipe location. If you're doing this with existing piping like I am, you're probably going to have to remove a bunch of the straps so you can make enough slack so you can squeeze this stuff all in place, or just use a shark bite type slip fitting that you'll get this in place either way. Sweating joints take some practice. You're basically applying heat, and the opposite direction you're applying the solder and drawing that into the heat. You really have to get the pipes hot enough so that the flux is basically bubbling. And the only thing I can really tell you is to watch some helpful videos online, and also just practice on the bench. Get some fittings, some pipe, and really practice before you do this on your first job. It helps a lot. It helped me a lot. I like to clean the joints off with a rag. You can heat it up with a wet rag, and it really makes a nice finished joint. So now I've shut off the water heater and isolated it, and I'm cutting into the hot water supply. Basically the same process, let it drain out and start putting the fittings together.
It's okay, I'm gonna make another one. So you're gonna have your sink now.
Good. Good.
What a pain in the ass. It's not easy doing this when you're trying to retrofit, because all the pipes are all fixed.
Yeah.
Well, we're gonna see if this thing leaks. God willing, it won't.
So now that all the pipes are in place, I'm going to put some clamps. I'm actually using these plastic ones for the first time. Usually I use copper. You want to make sure that you really are careful to not use dissimilar metals in contact with the copper pipes. They'll cause galvanic corrosion over time and pinhole leaks throughout your house, which has actually happened in my house before due to negligence of other plumbers. Next, I'm going to work on the PVC drain, and I'm going to apply some thread tape on all these threaded fittings to make sure we get a good seal. Working with PVC pipe is really easy. You can cut it to size with a hand saw, with a power saw, and then all you really need to do is to follow the same principles as you do with a copper pipe. You want to deburr the inside, clean the outside, and make sure that you make really nice clean connections. Because this is a direct inline pump, I'm actually going to put a union connection so that I can unscrew this and take this apart if I ever have to service the pump or replace it. If you don't do this, you're going to have to cut into the PVC later and then use adapters to glue everything back together. It's really annoying. Gluing the PVC joints is really easy. You're going to use a two-part system. It's basically a purple primer that you're going to apply very liberally to the inside surfaces of the fitting and the outside surfaces of the pipe. And then you're also going to apply clear solvent cement on both parts just in the same fashion. You want to glue the outside faces as well as the ends so that you can make a really nice watertight joint. When you assemble the PVC parts, you want to push them in place and make sure that they're fully seated, and then give it about a quarter turn and hold it for a few seconds, otherwise it'll back out. They have a tendency to push out when you put the glue joint together. And once you do one joint, it's pretty much rinse and repeat. Put this stuff together. Again, you can see I came off with a stem to a union, and then I came to a 90 and a 45 up so I could come right up to the stack. And just a note here, although I'm showing a check valve and then a ball valve, I actually flipped this around reverse and made a mistake after the fact, and you'll see in the end of this video where I corrected it. And as you build the pipe stack, you want to install some pipe clamps to make sure you take the load off the threaded part of the bottom of the sink. And next I'm going to take a measurement so I can get this vertical pipe and get a length on it for my fixed base and my upper assembly that I'm going to go into. And then I'm also going to take that piece and mark on the existing drain line where I can cut into it with a T. And it was right at this moment as I cut this pipe open that I discovered that the previous owner had just dumped mountains of fat down this line, and it was completely caked. I had to snake it out. And you'll notice here I actually also put in a Y fitting so that I could put a proper clean out, so that in the future I can snake this thing and clean it out if I need to. There wasn't one previously. Now that I've got these joints glued, I'm going to put this in place and hold it until it sets. So now all my pipes are in, and the last thing I'm going to do is level the sink and screw it to the floor. I'm just going to take a level, check it side to side, and I'm going to try to pitch it forward just a little bit so that the water runs into the basin. Even though it's already sloped, it helps. So I'm using a hammer drill and then also just direct depth cons with the low torque settings so I don't strip them out, and that'll secure the legs to the sink in place so you never move it. Okay, so the last step on this sink install is to adjust this ball valve to control the flow rate. Because this pump has a greater output than what the sink can give it, it's going to cycle on and off as it's filling up about a 4-inch stack. Because this doesn't have a reservoir or catch basin that most sump pumps do, where it's throwing a couple gallons away at a time, it's going to run as you're using it on demand. But if you don't adjust this, it's going to cycle on and off and probably not give you a long life of this pump motor, and it's kind of annoying. So I'm going to show you how we do that. First, we're going to open up both hot and cold water.
those are open, pump is plugged in, and now we're going to run the water, and you're going to see what I mean right away. So I'm going to do these like half. And you're going to start to hear the pump cycle, hopefully that picks up on camera. And it's going to cycle on for a half second and just shut off. We don't want that. So what we're going to do is adjust the ball valve. And what you imagine is, I think the flow rate is double what the pump can put out, what this sink is probably putting out. So we're probably going to have to close this valve almost 50% or more. And you'll see as you adjust this valve, it'll stop cycling. That frequency will change. So you want to adjust this valve, and you're basically limiting the water that's flowing through it in a way that this pump runs continuously. So that by the time you shut this sink off and this basin is empty, the pump will go off. So that's it. Very easy to adjust, and you get it right to the sweet spot of what your water flow is. So one of the last tips on this build that I'll give you is this inline check valve. I would go ahead and throw this in the garbage, as most people reviewed in the product descriptions. They said that this is terrible, it leaks, it doesn't make a positive seal. So I went out, when I bought these other components, I bought this inline check valve at Home Depot. It's only about $10. This one seems to work very well. I haven't had any trouble with it leaking. The problem with this check valve, as people do complain about in this pump description, is that this kitted check valve leaks. And even with a 6-foot head minimum above it, which you're supposed to have, it does not close and make a good seal. And what happens is that water leaks through that rubber gasket that's on that little flapper and goes right to the pump, and it'll end up cycling this pump all the time. So I wanted to avoid that and just use a good equipment from the beginning. There's always, you only have to install this once. So use good stuff, do it right for the first time. It's not that much more expensive.
So here's a quick overview. You got your pump, your union joint, your ball valve, and then your check valve above that, and then we come up and tap right into the existing drain, and we have our clean out there now, so we can clean out this drain if it ever happens in the future. And then on our copper pipe side, we have the hoses coming in the bottom of the shutoff valves, and that basically taps in place. I've got a shut off for my cold water supply, and the hot water supply is a shut off, just certainly off camera, you can't see it in this view.
So that's pretty much it. It wasn't a terribly complex project. It's probably not going to be your first plumbing project, but for me this is probably my own second or third install for plumbing, and it actually went really well. I'm not an expert in sweating pipes. I still have a lot to learn in applying heat the right way, but it wasn't outside of my wheelhouse, and that's why I took it on. All in all, this probably cost between $350 – $400 for all the parts and components. So it's a fairly inexpensive project. I imagine that a plumber is going to charge you more around $800 to $1,000 depending on your area. This is quite a bit of labor, especially if you're roughing into existing pipes. One of the biggest challenges with existing copper pipes is that everything's, not always, but it's supposed to be rigid, and you've got to remove all the clamps in order to get the stuff in place. Of course, you can always use slip fittings. You can use shark bites. I've used them on other projects. They work great. I decided to sweat this because I knew that this is going to be here for a long time and I want it to last. As always, if you guys enjoyed this video, please give me a thumbs up, share this video, like it, comment below. If you have any questions, I'd be happy to answer them. I do a wide variety of videos like this, stuff around the house and the shop. I try not to do just woodworking or technology videos, but also practical videos like this, where you need something done in your house and maybe you can't afford it and you want to learn how to do it too. As I said, I'm not an expert, but I do my best to do the best work that I can with the knowledge and tools that I have. Thanks for watching. See you guys in the next one.